Hello everyone, welcome to this session. So after we have a basic understanding of the neural network, so in this session we will introduce this structure, go a little bit deeper into it. So as we have seen that in the last session, the neural network is like this: the input, the hidden layers, and the output layer, right? And there are connections between them. So now we look at this node, right? This is like a neuron in real world, right? So in real world, a neuron, what does it do? In biology, is activated and pass a bioelectric signal to the next neuron. So we can do the same thing, right? For this node. So this node can also be activated and do some calculation and pass a result to the next node. So the node-by-node connection, the neural network is constructed. So in this way, the signal is processed and passed between the neurons. So now let's see how a neuron, the process and activation. First of all, we introduce some activation function. So the goal of the activation function is to introduce some nonlinearity. Because of the real-world data, many of them are nonlinear. So in order to make the neural network have the ability to handle the nonlinearity, we need the activation function. So there are many of them. So here I'm showing the three most popular used ones. The first one, the sigmoid function. We can see the formula is like this, and the shape is like this. So we can see that for input, and it will be transferred to a number between 0 and 1. We can see here, right? And the second one, we call it the tangent hyperbolic. So we can see this is a figure. Formula is here. So for any input x, we can transfer it to a number between -1 and +1, following this shape, right? Third one, we call it a rectified linear unit. We also call it ReLU. So for the ReLU function, when the x is larger than 0, it becomes itself, and otherwise is 0. So this is three widely used functions, and you can see here in the live scripts. Now, after knowing the activation function, we can study more how a neuron processes a signal. So a neuron, we use three things. First is the weight, and this weight can come from the connection, right, to it. And there is a bias inside the neuron, and there is an activation function inside the neuron. And the calculation, what we can do is multiplication, the addition, and activation. So here I will show you an example. Consider there is a neuron, right? And there is an input. Maybe this input is from another neuron. And this is I1 equals to 0.8. Then I see a weight, this is 0.5, and I have a bias of the 0.12. Then I can calculate it based on this formula. W1 multiply I1 plus P1. We can get a result, 0.32. Then we can go to the sigmoid function. You see this x is here, right here. Then using the sigmoid function, we calculate the result, 0.579. So in this way, after this calculation, the input of this neuron is 0.8, and the output is 0.579. And this output will go to the next neuron. So, okay, so this one, 0.579 as the input. We have another weight, another bias. So we can do the same thing. We use a W2 multiply I2 plus P2. We have a result. This time is minus 0.21. And you can see this value comes here, right, using the sigmoid function. Or we can change another activation function, right? It gets a result out. So then the signal will transfer using this route. So step by step. And eventually we go to the output, right? So that's all for this session. Thank you very much for listening. Bye-bye.